In this video, we're going to talk about cis and trans isomers. So let me draw you two structures and try and understand the difference between them. So the left one's going to be trans, the right one's going to be cis, and I'll draw the substituents in a minute. So what do you notice as a difference? Now I could change it so that the chlorine can be on the left like it is on that side. So the difference is that on the cis isomer, the hydrogens are on the same side. On the trans isomer, the hydrogens are on opposite sides. So this one's down, that one's up. Now it doesn't just have to be hydrogen. Any groups that are identical, that are on the same side like this, it's going to be a cis, and then if the same group are on opposite sides, it's going to be a trans. So let's go through another example to demonstrate this. So this time it was with a double bond with an alkene. We had a double bond in the middle between two carbons. In this case, let's look at a ring structure. So let's take cyclopentane. And let's say we have a wedge, two wedges, actually a wedge and a dash. So the dash is going into the page and this is coming out of the page. And let's say at the end we have NH2 groups or amine groups. So notice the difference here, that the trans isomer, one is going to be into the page, one's going to be out of the page. On the cis isomer, they're both coming out of the page. Now the cis isomer could also have it so that both of them are going into the page. They just have to be looking the same. Now there are some situations where you cannot have a cis and trans isomer. Those situations would be like this. Let's say we have a double bond, right? And actually I usually draw bromine red, so let's do that. Let's put a fluorine. Let's say we have, in this situation you cannot have a cis trans isomer because you have, on one side you have two of the same group. So when you have a situation like that, you cannot have a cis-trans isomer, regardless of what you have on the other side. The other side could be CH3 or CH2, CH3H. If you have two of the same group on one side, it cannot be a cis or trans isomer. Now let's go ahead and talk about a few examples, and this will be some practice for you. Try and figure out if you can have a cis or trans isomer within these structures, and try and figure out if you can, try and figure out if it's cis or trans. Feel free to pause the video and work on these. So the one on the left, when you draw bond line structures, there's always going to be invisible hydrogens. So each carbon on one end is going to have four things attached to it. Here it has two, because 1, 2. So it's going to have, to get to 4, it's going to have two invisible hydrogens. Now, as we said, if we have two of the same group on one side of a double bond, it cannot be a cis or trans isomer. It doesn't have cis-trans isomerism, so this one doesn't have it. In this situation, there is going to be an invisible hydrogen that goes down and then one that goes up, and they're on different sides. So One is up, one is down. So this is going to be a trans isomer. The cyclopentane one, once again, the end of this double bond is going to have two invisible hydrogens. And in this situation, you have two of the same group on one side, so you cannot have a cis-trans isomer. On the bottom right example, one side of the double bond has an invisible hydrogen. The other side has two methyl groups. These are methyls if they have nothing at the end written on them. And so you have the same group on one end of the double bond, since this is the double bond. So therefore this also cannot have cis-trans isomerism. So these ones don't have it, but this one does, and it happens to be a trans. So I hope that was helpful, and thank you for watching.